Hello and welcome to Container Bytes. In a previous video, we took a look at different GPU sharing strategies in GKE. In this video, we're going to take a look at one of them in particular, time sharing. Let's talk about it. GPU time sharing is a GKE feature that lets multiple containers share a single physical GPU attached to a node. Using GPU time sharing, you can more efficiently use your attached GPU and save running costs. Here we create a new node pool called sharing on our cluster Gen AI. The machine type is A3 high GPU-8G and the accelerator type is NVIDIA H180GB. Here we can see the GPU sharing strategy is set to time sharing and max shared clients per GPU is set to 48, which is the maximum number of clients per GPU you can set in time sharing. We already created this node pool, so you can see keep control get nodes, and you'll see our sharing node has been already created. We can also see the detail of this node by running keep control describe node and the name of the node. In the node's allocatable and capacity, we'll see the number of pods is 256, which is the maximum number of pods you can have in a single node, which we set during node pool creation. The number for nvidia.com/GPU is set to 384, which is 8 times number of clients per GPU, so 48 times 8. Here we have an example of a simple job that is going to consume this GPU. We want 384 completion of this job with parallelism set to 192. We could set this number to anything, but because the upper limit of pods available on a single node is 256, we set it to a number lower. So this is gonna run through twice to run all our pods in this node. We set the appropriate node selector with time sharing and max shared clients per GPU at 48. We can go ahead and run this with keep control apply-f time sharing.yaml. We can see how many pods we have created by running keep control get PL and passing the output to word count to see how many lines of output we have. We would see so far we have 193. After these jobs are completed, we will run another copy of them. So in total, we should see 385 lines being outputted. As you can see, more and more pods are spinning up. Here we see the line count at 385. We can do keep control get jobs, and you will see almost all of them have been completed except for a few of them. Run it again. Now you can see all 384 jobs has completed. We can grab any of these completed jobs. So keep control logs with the name of the pod. We'll see the output is set to GPU 0, NVIDIA H180GB, and name of the GPU that this particular pod is seeing. GPU time sharing can work alongside multi-instance GPU. So you could set a GPU partition size up to 7 chunks for each of the physical GPU that you have on A100 or newer GPUs, and then take each of those chunks and allow multiple clients to connect at the same time. So here we have an example of that. We are setting up the similar node pool of H100, but now we're also setting a partition size of 1G10GB, which is going to partition our 80GB GPU in 7 chunks, each with 10GB size. And then we're allowing 48 clients to connect to each of those chunks. So if I were to describe, you'll see something like an NVIDIA.com GPU of 2688 total GPU in this one node, which is, again, practically absurd. There is no real reason you want to do something like this other than having maybe this number that you can show other people that I have a single node with 2688 GPU on it. But there is no real practical reason to have that many. You could do something like chunk the GPU into 4 hardware isolated partition, and then each of them gets like 3 or 4 clients that can connect to it to do work asynchronously. Before you decide on time sharing for your next GPU project, you need to know a few limitations. Number one is memory limits are not enforced on GPU, so you'll have to do that per workload. If you have a workload that is particularly noisy or using up too much resources, that can cause out of memory issues for other workloads. The maximum number of clients you can attach to a single physical GPU is 48. When planning your GPU time sharing configuration, consider the amount of resources you would need for each of your workload for the best performance and responsiveness. In this video, we learned about GPU time sharing and how to enable GPU time sharing on GKE. If you want to learn more about other GPU sharing strategies, you can find those videos here and here on the page summary. Thanks for watching.